All right, guys, so now that we kind of finished going over some more of those equations, we're actually going to switch over to something called expressions for a moment. So when we talk about expressions, just want to make sure we review the difference between an equation versus an expression. Okay? An equation has an equal sign. An expression has no equal sign. So whenever they ask us to write an expression, okay, that's going to be no equal sign. If they talk about equations, we will have an equal sign. Now, so this says write expressions where letters stand for numbers. Just a heads up, we know the math word for that. And we're talking about, we're going to have expressions with variables inside of them. So we're going to take a minute and look at this first one here. And this says algebra talk when x is 6. So they're going to give us all of these expressions. Remember, no equal sign, so that's an expression. And we're going to have to see what happens to that expression when x is 6. So for this first one, we have x plus 4. Now, we are going to substitute x in for, 6 in for x. X is gone, 6 is going to be in its place. So instead, I'm now going to think of this as 6 plus 4, which is the same or equal to 10. So we took this expression, we put in 6 for it, we substituted in, and then we made it an equation and saw that it was equal to 10. Expression, equation. Expression, equation. Okay, let's do our next one. This one's now saying 7 minus x. Instead of x, we are substituting in 6. So we get 7 minus 6. This is currently an expression, but I can say that that equals 1. Now, it's an equation. Let's look at our next one. X to the power of 2. Instead of it being x to the power of 2, this is going to be 6 to the power of 2, okay? Which is equal to 36. Now, if we don't remember exponents, here's just a little quick exponent review. Okay? If I have something to the power of 2, let's say I do 3 to the power of 2, that means I write 3 2 times. 3, and there's multiplication in between, times 3, which in this case gives me 9. If I had 4 to the power of 2, that means I write the 4 2 times, 4 and 4, and they're being multiplied. 4 times 4 equals 16. So 6 to the power of 2 was really the same as I write 6 2 times, 6 times 6, which gave me that 36. Okay, that was just a quick little exponent review. All right, for my last one, this is 1/3 x. X is 6, so 1/3 times 6. Now we know this is the same as 6 times 1, which is 6, and over 3 is the same as dividing by 3. So 6 divided by 3 gives me 2. Okay, that was our first warm-up. Let's take a look at some of our other problems for this unit. So we're going to be taking a look at how can we find essentially patterns within these sets of numbers. And we're going to be doing that with some tables as well. So let's just take a look and read through this first question. Lynn set up a lemonade stand. She sells lemonade for 50 cents per cup. So remember, per means 1. So it's 50 cents for 1 cup. Complete the table to show how much money she would collect if she sold each numbers of cups. Now, this table is horizontal. There's absolutely nothing wrong with that. You can 100% do it as a horizontal table. I prefer my tables to go up and down vertically, so I'm just going to redraw this vertically because that works for me. We've got money and we have cups. Okay, this is telling me that it is 50 cents per cup. So it costs 50 cents for every 1 cup. They want to know about 12 cups. Well, how do I get from 1 to 12? Well, I multiply by 12. So that means I need to take 50 cents and multiply it by 12, which means I'm going to get, or it's going to cost me $6. All right, so I can say that it's $6 for my 12 cups. Okay. Next, I'm going to do 183. Let's change colors just so you can see that piece a little bit better. Let's do the blue. All right. How do I get now from 1 to 83? Well, I multiply by 183. So I'm going to take my 50 cents and multiply by 183. You end up with 91.50. So it costs 91.50. Now this next one you might notice is asking us now about not a number anymore, but a variable, C. They're asking about a variable C. Now, when they're doing that and they start asking you about a variable, they're starting to ask you about what patterns did you see. Now, I knew that for every 50 cents, I was getting 1 cup. Or for every 1 cup, it would cost 50 cents. This was my starting ratio. Okay, then I wanted to get to 12 cups. To get from 1 to 12, I multiplied by 12. Now, they did the same thing. Then they want 183. Well, to get from 1 to 183, I multiplied by 183. What if I wanted to get to 7 cups? Well, I would multiply 1 by 7, 50 cents by 7. What if I wanted to get to 100 cups? Well, I would take 1, multiply by 100, 50 cents, multiply it by 100. So this C is representing, well, how do you get to any number? Is there a pattern? And there is. How would I get from 1 to C? I would multiply by C. Just like to get from 1 to 12, I times by 12. To get from 1 to 183, I times by 183. To get from 1 to C, I times by C. So on this side, I'm going to times it by C, which means I'm going to have 50 cents times C. So for C, it's 50 cents times C. Okay, so now this is the point where we're going to take this expression, because right now 50 cents times C, that is an expression. I'm going to change it to an equation that we can solve. Take a look at this question. How many cups did she sell if she collected $127.50? Be prepared to explain your reasoning. Well, over here, we figured out that the cost is always going to be 50 cents times how many cups you bought. But in this case, now they're telling us what that's going to equal. We know that's going to equal $127.50. Well, we know how to solve these types of problems. 50 cents times something equals $127.50. Well, the 50 cents is being multiplied by C. So that means I can come through and I can divide both sides by 50 cents to figure out how many cups she sold. So we're going to take 127 and 50 cents and divide it by 50 cents. And I can figure out that that means 127 and 50 cents divided by 50 cents means she got 200, or she sold 255 cups. Okay? To 255 cups. Just taking a look, see what we got left. Okay, let's take a look at our next problem now. Okay, Elena is 59 inches taller than some other people than Elena. Okay, complete the table to show the height of each person. Okay, so they're telling you that Andre is 4 inches taller than Elena. So, Andre is 4 inches taller. I know Elena is 59 inches. Andre is 4 inches taller. So how do I get this? Well, I'm going to do 59 plus 4. What do you get for 59 plus 4? Well, you get that Andre is going to be 63 inches. Okay, Lynn apparently is 6.5 inches taller than Elena. So then I'm going to get 59 plus 6.5. That means Lynn is going to be, 65.5 inches tall. Now, Noah, they don't tell us his height. They're just saying that Noah's going to be an unknown height. So how would we find Noah's height? Well, for this one, it took 59 and added the 4. 59 added the 6.5. I'm going to take 59 and add Noah's height, which is being represented by the variable of d. Here is our expression. Now they're telling us that Noah is 64.75 inches tall. How much taller is he? Well, we now know then that 59 plus d equals 64.75. I'm trying to solve for the variable d. So I'm going to subtract 59 from both sides. Okay, I'm going to find out then that d equals 5.75. Okay, let's take a look at our next one. All right. Claire is 5 years older than her cousin. How old would Claire be if her cousin is 10? Well, if Claire is 5 years older, that would be 10 plus 5, which means Claire is 15. If her cousin was only 2 and Claire is 5 years older, that would be 2 plus 5, which means Claire is 7. Well, what if we don't know Claire's age? I'm sorry, what if we don't know her cousin's age? Then it would be x plus 5. It'd be whatever that cousin's age is, plus 5 more years. Now you're going to say Claire is 12 years old. I'm going to answer this up here, guys, just because there's just not enough space. If Claire is 12 years old, how old is the cousin? So we take that expression and we now say that's equal to 12. So I'm going to take this. I need to get x by itself. It's currently being added by 5, so I'm going to subtract 5 from both sides. And x is 7. So 7 years. Okay. We're going to do this one. Diego has 3 times as many comic books. How many comics books does Diego have if Han has 6 comics books? Well, we know this is going to be 6 times 3. So it's going to be 18. What if I don't know how many? Well, it's going to be the amount I don't know times 3. It says right here, 3 times. So if Diego has 27, that'll be equal to n times 3. If I want to solve this and get n by itself, I'm going to divide both sides by 3. And 9 equals n. Okay, guys, we've got 2 more. I do want you to try 4 on your own. But we are going to do 3 together. But 4 is going to be one that I want you guys to practice on your own. I think we'll be pretty good with that one. Okay. 2/5 of the vegetables in Priya's gardens are tomatoes. Okay. How many are tomatoes in Priya's garden? If she's got 20, she's got X. So this would be 20 times 2/5. 20 times 2 is 40 over 5, which equals 8. What if we don't know how many? Well, that's going to be x times 2/5. Okay, this is the part I wanted to practice. This is those fraction ones. So now we're saying if it's equal to 6, that'll give me x times 2/5. Now this is the type that we practiced in lesson 5. X is being multiplied by 2 and divided by 5. So we've got 2 pieces going on here. We've got to address them both. Well, if I'm being multiplied by 2, I know on both sides I have to divide by 2. But x is also being divided by 5. If x is being divided by 5, I need to multiply both sides by 5. So 5 times 6 is 30. There's nothing under the 6, so I can put a 1. 2 times 1 is 2. So x is equal to 15. All right, guys, that's all for today. We are going to keep going through this the next couple days. Try 4 on your own and then see how it goes.